Okay, hi there. Welcome to my 21.4 Environmental Conditions assignment. Um, Temperature is something that people have become very familiar with within sports because of all the locations where it can be played nowadays. Whether it is in extreme warm or cold conditions, it is always a factor to be aware of when analysing performance. The normal body heat for humans is 37 degrees, but as soon as we start exercising, this can change because of the external factors. If it is not kept monitored, then it could result in some temperature-related illnesses such as hypothermia. The term homeostasis is used to describe someone who is completely neutral and is not exercising and is completely relaxed. The way in which the body regulates the temperature is that the receptors, called thermoreceptors, detect any change in heat and send signals to the hypothalamus in the brain. This then triggers certain physiological responses such as sweating or the hairs on our bodies extending or flattening in order to trap or release the heat. High temperature, the responses to high temperature are that the sweat glands are activated by the hypothalamus, and the reason for this is because the sweat acts as a coolant that will cool our skin and stop us overheating too much. Another physiological response is when we are hot is that the hairs on our body flex out in order to allow to allow more of the skin to be showing, which will then allow heat from our warm blood to escape through the skin. The reason that we actually get hot during exercise is because one of the byproducts of muscular contraction is heat that has to be excreted in some way. Otherwise, we can suffer from things such as hypothermia or dehydration. The physiological responses of sport taken cold in cold conditions is that the hypothalamus triggers the hairs on our body to flatten in order to stop as much heat leaving the body as possible. Another physiological response is that the capillaries in our limbs vasoconstrict in order to keep the warm blood away from the areas where the skin is thinner and can escape the body easily. Instead, more blood is within the organs, and with the capillaries vasoconstricted this way, the blood pressure is also increased, meaning that the blood flow is faster, and therefore the warm blood is pumped around the body at a faster rate. The effects that low temperature can cause on the body is things such as hypothermia, which can result in things such as disability or even sometimes death. The effects of low temperature on performance can sometimes be very significant as it takes a lot longer to warm up because the muscles are a lot less elasticated when they are cold, which can also mean you can have injuries such as pulled muscles a lot easier. Altitude is something that can have huge effects on aerobic and even anaerobic performance. Sea level is the lowest that land-based sport can ever be performed at, and this is where air has the most oxygen. However, when it comes to places such as West Africa, they are much higher up at altitudes up to 4,000 feet where people are living. Athletes choose to train in these locations because it puts their body in a situation where they are restricted of oxygen, which forces their body to produce more red blood cells in order to account for the oxygen storages to be larger, so they do not fatigue as fast. Therefore, when they go back down to sea level and are competing in normal conditions, but still have a larger oxygen supply compared to the athletes who trained at sea level, it gives them a very large advantage over them as it improves their endurance so significantly. The events that really rely on the aerobic system giving them oxygen are long distance events that require a low intensity but high duration, steady state exercise. For example, the 5,000-meter race or marathons. The gaseous exchange at sea level when exercising does eventually result in fatigue if the aerobic system is unable to provide the oxygen that the muscles are supplying. But when athletes are at altitude, this whole process is sped up if the athlete's body is not adapted to these conditions. The reason for this is that the lungs are not able to breathe in the normal amount of oxygen because of the lesser volume of it in the air. Therefore, when non-saturated hemoglobin arrives at the alveoli, they are sooner not able to be fully associated because the alveoli does not have as much oxygen, which results in sooner than normal aerobic fatigue. The responses to hypoxia are that hyperventilation can occur at altitude because the body is not used to the lesser amount of oxygen that it is being exposed to. Therefore, the body almost panics and it causes us to start breathing uncontrollably fast in order to get as much oxygen in as soon as possible. Another response to hypoxia is something called tachycardia. This is where the heart rate is above 100 beats per minute. This happens because, again, the lack of oxygen at altitude means the blood is less saturated per hemoglobin molecule, which therefore means the blood has to be pumped to the muscles in order to get more oxygen to them. The effects that altitude actually has on performance is that the VO2 max is decreased because of the lesser amount of oxygen for the body to use, therefore the amount used goes down. This means that when exercising, athletes get aerobically fatigued a lot faster than they were when they're at sea level. Anaerobic events, on the other hand, such as the 100-meter sprint or long jump, are actually benefited at hypoxia because they are using the anaerobic system, which involves no oxygen consumption at all. Therefore, they fatigue at normal rates, but they also benefit from the thinner air because it results in more air resistance, which allows them to, for example, jump further in a long jump.